So I've got Jonathan here, who's a member of the product management team, talking to me about a change we made to polling tentacles. For those who aren't aware, polling tentacles are one of the ways in which you can connect remote machines to an Octopus instance. And we have a change that we've made, Jonathan. We're allowing polling tentacles over standard ports. Is that correct?
Yeah, that's exactly correct, John. Maybe before we dive straight into the fun bit of how it all works, I'll just give you a bit of background as to why we've made this change. Customers were telling us that the conventional way the polling tentacles worked using this non standard port of 10943 was giving their security department and them a little bit of a headache because
Yep.
security doesn't expect traffic to be on this strange looking port, and the firewall rules block it. So our customers are saying they have to go to their security department, they have to get exemptions, and that can be a long drawn out process for bigger customers with high governance. Could be anything up to 6 months,
Oh,
of
wow.
backwards and forwards to finally convince them, and then security is still not really happy. So, or they might embargo it altogether. So, this development was all about removing all that friction and those headaches and just making it a lot easier to use Octopus Cloud. And this solution is focused on Octopus Cloud, or this video is focused on Octopus Cloud, but we'll have a couple of comments towards the end on self hosted.
Yeah, so the change we've made is we're going to a standard port, 443, which I guess is the standard port used for SSL, TLS, and all that fun stuff over secure channels. Is that right?
That's exactly right, John. So security departments sort of expect encrypted HTTPS traffic over 443. So it's something they're used to. It's comfortable, and the firewall port, outgoing port, may already be open. So there may be nothing more to do.
And so on the diagram that you're showing here, it shows how typically when a polling tentacle connects, it in the old times, I guess before this change, it would connect via 10943. And then if it came into if it was hitting Octopus Cloud, which is our SaaS offering, it would do so through that same port, which you would have to open as well. Now, this is done all over 443, comes in through the cloud, and then we do a reverse proxy, which I guess means that from the side of Octopus Cloud internal, your cloud instance, that all comes in through a standard polling tentacle, but we communicate on the outside. Nothing changes. It's all 443. Is that right?
That's correct. So, as far as the customer's installation is concerned, it's coming across 443. So, out of their firewall on 443. But our Octopus server instance in Octopus Cloud is still expecting the traffic to be split between the web app API and the polling tentacles across those two ports. So that's why we've implemented this reverse proxy. Just to give a bit of background as to the change, if I can draw your attention to the two URLs that are listed at the bottom. The top one is your current Octopus Cloud URL, so your instance.octopus.app. What we've done is to configure a second URL by prefixing the word polling in front of your URL. So that now reads HTTPS polling.yourinstance.octopus.app. And in short, it's those two URLs that now distinguish the traffic between the web app and the polling tentacles. And that's how the reverse proxy knows which traffic to redirect to the server on 10943 and which to let flow through onto 443 as before. The one advantage of doing it this way is that we haven't had to make any change to Octopus Server. So this new way is completely backward compatible with what's gone before.
And the other thing that's nice about this is around observability, right? I know that some folks want to keep close tabs on their network traffic. And so by having this sort of DNS prefix of polling dot, this alias, they'll be able to easily spot where those polling tentacles are connecting from rather than having to look at some arbitrary port, for example. So That's great. What are some of the things that folks need to be aware of? You've provided a nice summary here.
Yeah, John. So unsurprisingly, there is a minimum tentacle version number to be able to use this, and it's listed there 6.3.417 or later. And therefore, any existing polling tentacles that you wish to use this capability would need to be upgraded to that same version number or a later one. Um, The other question is, can I have a mix of polling tentacles, some on 443 and some of 10943? And this may be arise if you're in a program of moving existing polling tentacles to utilize this new capability. And the short answer is yes, because of that backward compatibility, this all works. So you can have a period of having a mix and it all just works. Now, we have been talking about Octopus Cloud, and that's what this video is really focused on. But it does start begging the question, what about self-hosted? Can I use this? And the answer is that you can for single execution node instances. The one proviso is that the customer will have to implement that reverse proxy. So we've done it on Octopus Cloud, but now the customer on self-hosted will have to do the analogous thing to separate that traffic based on the different URLs. So it works on, if you've got a single self-hosted Octopus installation, it'll work there. If you've got the single execution node and multiple UI nodes, it'll work because you've got that single execution node. But multiple execution server nodes, it's possible, but that gets a whole lot more complex, sort of out of scope for this video. So just to summarize on Octopus Cloud only comes in this single server instance. So this will work if you've got Octopus Cloud. This is available to you. That's the simple part. Multi-serve in Octopus Cloud is just not applicable at this stage.
Fantastic. Hey, this is great. I'm sure this will help with folks trying to get adoption of Octopus within their IT departments, which is great. And thanks for articulating these changes. This is great to see.
Thank you, John.